on yours. So today we're going to focus on solving, but before we do that, here is a warm-up going over what we did last Friday. So we have the roots, which are the zeros, the x-intercepts. So the equation for factored form is y equals. You needed something equals f of x, g of x, y equals something equals to make it an equation. And then factored form is always x minus the root. X minus the root. Because you can think about when we solve, we get the opposite signs from our factors for the solutions. So then standard form, we multiply the factors together. FOIL, box method, distribute. So I'm going to go x times x times -7, 5 times x, 5 times -7, and then our final answer is combining the like terms. What questions do you have before we get to part C? Oh, wait, I got a question. Why is it -7 and not -5? Are you talking about in the multiplication here? Yes, and the factor form. Okay. So if you look back at your notes from Friday where we wrote the forms, factored form was x minus the number, x minus the number, where the numbers are the roots. So since one of the roots is -5, -5, it's x minus the negative, which is plus. Then when you multiply, this 5 times x is positive, and then the x times -7 is the -7x. Any other questions before we get to the vertex form, which is more work? Okay, so vertex form, we take our standard form, and the first thing we do is move the constant to hang out, whoops, that's supposed to be an equal sign, to hang out with the y. Because when we complete the square, we have to fill in these blanks. So half of -2 squared is 1 on both sides. Combine your like terms and factor the right. And then our last step, we're just going to isolate the y. So we get y equals x minus 1 squared minus 36. What questions do you have?
I have a quick question.
Yeah.
So just because you know, you have the 30, you move the 38.6 from one side of the equation to the other. Oh, never mind. I did it wrong. Never mind.
Okay. All right, so next chat question I have is about homework and quiz. Oh, is that a, go ahead, Johnny.
Well, this is like, remind me what a parabola is. I think I came in late, so maybe you explained it, but.
That graph.
Oh, that? Like the U?
Yeah, the x squared graph. Quadratic makes a parabola.
And then, and so we were just taking like the roots and inputting them into like the factored form and then converting it to vertex.
Yep.
Okay. Yeah, I don't know. I just need a refresher.
That's fine. Okay, so I got another chat question before I answer. So the first question I got was about homework and quizzes over break. I got that for you on the next page. The Math question though is, so converting to vertex form from standard form is similar to completing the square, but you just don't solve by taking the square root. Yes, it's the same process of making that perfect square trinomial that factors to the binomial squared, but we're not solving, so we don't square root, and there's no variable to solve for. I have an x and a y to make my equation. Okay, so to get to the question about work over break, no, we are not going to have any new work over winter break. It should be a break for everybody. We do have a new topic today with some homework, but if you finish it today or by tomorrow with the check-in day, then you have no work over break. Get it done. We're going to have no new math over winter break. There's no quiz this weekend. Get your homework done tonight. If you want to meet tomorrow for a check-in time, so there is no schedule as far as the Zoom check-ins tomorrow. Some teachers are just doing check-ins by email. I can be available to you on Zoom if we set that time up today. So if you want to email me this afternoon about a time to meet tomorrow, I will write you back a specific time we can Zoom tomorrow if you have any questions. All work has been graded, at least as of 12:30. I don't know if someone submitted something last 10 minutes. So if you want to take the requiz for SLT 0 to 2, the solving and the forms of the equation requiz, get your corrections done by tomorrow afternoon, so that way I can give you the feedback and the passcode for you to take your requiz before winter break. I'm not going to be checking Canvas every day for submissions. So during break. So if you want to take that requiz tomorrow or over the weekend after the holiday, you can. I just need your corrections submitted before Wednesday afternoon so I can give you that feedback and the passcode for the requiz. Are there any logistical questions about any of this? Did you take out your plan book and write this down, write down the homework? Take a screenshot. That's fine too. And then I'm going to scroll down in a second. The math shirt I'm wearing today has a lot of detail on it, so it's kind of hard to show you through my little Zoom camera. So I took a picture of it. This was my other Hanukkah present from my family. It's the math dance shirt. So wait, I forget who was asking me about the parabola question. Here you go. Here's your x squared parabola. A line. But one of them's wrong. It's a graph we've already done this year. Can you find the wrong graph? You're now terrified of 1 over x. 1 over x looks like this. It's just hard to do with hands. It's just 2 pieces. Don't be scared of 1 over x. But can you find the wrong one that we've done this year? Yeah. I'll give you a hint. It's on the bottom row. A few of you are chatting me. It's the log graph. The log parent function looks like this. They have it reflected. That's not right. Instead, I should have made this person with their arms this way. Oh, I guess no arrows on the end. They were close. They reflected it. All the others are the parent functions. Okay. Homework questions.
Wait, so Sorry, I'm so sorry.
No.
Wait, so we're learning like those graphs again right now?
So what do you mean? What do you mean?
Not graph, but like we're just gonna be working with all those different equations and stuff.
So lines, parabolas, cubics we did. This we might get to in the spring. I'm not sure yet. They have not given us the spring pacing calendar yet. Come on, math office, what are you waiting for? This you'll do in pre-cal. These we will get to, yes. Circle you did
Okay.
last year. This is exponential. This is a line. This is absolute value. So yeah, you've done most of them actually.
Cool.
Yeah. Okay, homework questions that was due Sunday? A lot of people came to check-in time yesterday. I was happy to help then. But if you didn't get your questions answered yesterday at check-in time, now's a good chance. Okay. So, oh wait, can I go over the steps for 7? Sure. Sorry, guess I just didn't give you enough typing time. I'm going to insert an image here real quick. So this is our decision-making process for the most efficient method. First, you have to have your equation in standard form. It is super. Not going to be square root method because I have an x squared, then an x. I don't have a quantity squared. So let's try factoring. Is there a greatest common factor? No. Binomial or trinomial? 3 terms. Is A1 or not? It's not. So let's see if I could box method or split the middle. 6 times 1 is 6. So we get 1 and 6, 2 and 3. They're both going to be positive, or because of the positive here and the positive here. Oh, so 1 and 6 works. I can box or split. I'll do box method. Okay, so for box method, the only way to multiply to 1 is 1 and 1. So this makes it a 6, and this is an x. So our factors are 6x plus 1, x plus 1. Oops, I forgot the 1. Equals 0. We're not done. Some of you on the quiz factored and then stopped. You got to solve. This is solving, not just factoring. So we've got 6x plus 1 equals 0. X plus 1 equals 0. Isolate each x. And there's our 2 roots, -1, 6, and -1. So we're going to practice more solving today. Actually, let me copy this in case I want it on my next page. Okay, so today we're solving SLT3, label that. So when you put it on your summary sheet, you know which topic this was. We're now going to solve radical equations. And here's our 4 steps for solving the radical equations. So I want to give you a minute. I want you to write the title, write the first problem here, and write down the 4 steps. What's a radical? The square root. That's left off this shirt because it's only the one, like you need one arm for that, not two. So the square root function, we studied that back in the beginning of the year. Whoa, that's crooked. Look like this. So really what we're going to solve for is where does this square root function intersect this line? The first step is to isolate the radical, meaning is the square root term by itself on one side of the equal sign? It is. If the question was written like this is not, the radical is not isolated. I'd have to move the 6 first to get it in this form before I go to step 2. Step 2 is square both sides, because that's how we undo the square root. So square root squared is x. But when you have a binomial squared, that means multiply the term by itself. I don't want you to go to math jail. Here's what I mean by that. If you do 2x minus 6 squared and just individually square those terms, that's not correct. It's not 2x squared and 6 squared. That's math jail. If I was going to draw on your paper in the building, you would get one of these. It's illegal. You can't distribute that power. Cannot distribute that. Instead, we're going to multiply with FOIL, box method, and multiply these terms together. 2x times 2x, 2x times negative 6, negative 6 times 2x, negative 6 times negative 6, so that is 4x squared minus 24x plus 36, not this illegal way over here. Can't do that.
And is there a particular order we're supposed to do it? So like it has to go from 2x to 2x first and then something else first.
You mean to multiply these?
Yeah.
So you have to make sure to multiply every term necessary. So the more methodical your method, the better. So back in Algebra 1, when you had two binomials, some teachers used the word FOIL, meant first, outside, inside, last. First, outside terms, inside terms, last terms. That's fine. Eventually for Algebra 2, we're going to get more than binomials. So FOIL being only 4 steps won't always work. So that's why I just say distribute and do my little swoopies to say, okay, 2x times everything here, negative 6 times everything here. Some students box method multiply, and you can do that. You take your binomials and then do length times width on all the little squares. So 2x times 2x, 2x times negative 6, negative, like, so if you fill in, it's the reverse of box method factoring because it's the multiplying, then here's your result, and that you can combine these like terms to the negative 24. So it's a personal preference on your method. When I write it out here, I am going to write it in standard form because now we're going to solve using the most efficient method for quadratics. I need to get this equal to 0. Then I have a chat question. So the radical was already isolated. Yes, for this problem, the radical was already isolated by itself on one side of the equal sign. Okay, here we go for solving with the most efficient method. not square root method. You have a question? No, okay. Maybe it factors. Is there a greatest common factor? No. Binomial or trinomial? 3 terms. Oh, A is not 1. Let's see if we can box method or split the middle. 4 times 36. That's my AC. You can do the traditional algorithm, 36 times 4. If you don't like that, because we're not using calculators, you can break your 36 into 30 and 6. Multiply each of those by 4 and add the parts together. So now that we know AC is 144, we need all the different pairs of numbers that multiply to 144 to check what what adds to negative 25. So to make that easier, if I break 144 down into my prime factors, it will help get all the pairs of numbers. So 144 is 12 times 12. Each 12 is, well, you can do 2 and 6 or 3 and 4. I'll go 3 and 4. And each 4 is 2 and 2. So I can think of 144 as 2 times 2 times 2 times 2 times 3 times 3. And the reason I want to do that is now all the ways to multiply to 144. 1 and 144. 2, and then I can multiply these all back together. 2, 4, 6, 6 times 9. Why aren't the 4s there? Okay, hang on. These 4s here? Yes, so they're the 2 times 2. So this 2 is a 4, this 2 is a 4. So like you can go 4, 4, and 9. So I'm going to use these prime factors to get the pairs of values that multiply to 144. Because this is a lot, like there's a lot to go through. And so if I go in order, it'll make it a lot easier. Okay, so I had my 2 multiple wrong here too, as well. Okay, so if I take this 2 out, what I'm left with is 8 times 9, which is 72. Then we got 3. If I take a 3 out, then I'm left with 16 times 3, or let's go 4 times, like you can do any order that you want to multiply there. That's 48. Then I can do 4. So let's see, 4, if I do 4, whoa, sorry. That means I use these factors and then I'm left with 4 times 9, no 5. I got a 6 because if I use a 2 and 3 together, that's 6, and then I'm left with 8 times 3, no 7 in there. Oh, I can do 8. Let me pick another color. So 8 would be these, and I'm left with 18. I can do 9. Here's my 9, and then I'm left with 16. And then 12 and 12 we knew, but we got there finally. Look, we're going to be able to box method because we can do -9 and -16. Whew. So just because A times C is a large number with a lot of choices doesn't mean it's not going to factor. All right. I'll do my box method over here. We got 4x squared, 36, negative 9x, negative 16x, and none of them are prime. So where do I want to start? Let me start with the 4x squared. Because I think if I make this 4x and 1x, then this would be negative 4. And this would be negative 9. And then that works. Ooh, we factored it. Set each factor equal to 0. And solve. And I'll pause there for a moment before we do step 4. What questions do you have before we get to the checking step? Yes. I'm listening to you, Ethan. What do you have to say to me? Okay, so step 4 is check. We have to check our solutions because the square root of x does not have a domain of all real numbers. One of these answers might be extraneous. Well, go wait and see if she, turn the light on, make sure just because she's late doesn't mean you have to be late. So we have to take the answer, substitute back in and see if it's correct. So we're going to take 9/4 and check that answer. And we're going to check 4 and check that answer. So you have to check both. We'll get to those questions in a minute. All right, let's check the 4 first. That's some easier arithmetic. The square root of 4 is 2. Is that going to equal 8 minus 6? That's 2. Yes, 2 equals 2, so 4 is an answer. Let's check the 9/4. Kind of an little extra work here with the fraction. The square root of 9/4 is 3/2. I can reduce this fraction. 2 reduces into 4 that way. So we get 9/2 minus 6. But I'm going to write 6 as 12/2 so that I can combine my fractions. And that's negative 3/2. That's not equal to positive 3/2. That answer is extraneous. It does not make the equation true. Go for it, Johnny.
So we figured out 2 questions, like how we figured out the 9/4 and the 4, and then we check them. Like one of those answers isn't going to be right.
Sometimes. So we'll talk in just a moment as I scroll down to those extra questions. I keep moving about how many answers should we expect to get.
Okay.
Okay.
And that's going to be like every time, like
Every
checking.
time. Every time you start with the square root, you have to check for extraneous solutions.
And how come we get an extraneous, like, I don't know if you know, but like why would an extraneous solution be a part of like?
I'll show you.
Okay.
I'll show you. That's what the question that I keep scrolling down will explain. Okay. So how many solutions did we find? You don't have to write this, just think. We found 2. but only one of them worked. Oh, wait, did all of them work in the original? No, just one. So let's discuss why that is. That's exactly where we were going. Why does that happen? This swoop-de-swoop here, that's that square root function that we graphed earlier in the year. And here's the line. They intersect one time at 4, which is the answer we got. That answer checked out and was good. But where did that other answer come from? Why was it extraneous? When you square root the x, when we squared the square root and undid it, and we get that quadratic, this was the extraneous solution. It created a solution when we were factoring to solve that was not part of the original 2 graphs. That's going to happen sometimes. The other types of situations that can happen, let's say we have this radical here, that square root, I can have a line that intersects it twice. This type of setup, when you have a square root equaling a line, would have 2 solutions. It's also possible, depending on the 2 equations that are set equal, to have no solutions. So sometimes we'll have 1, like we did on our first example. Sometimes we'll have 2. Sometimes we'll have none. And it just depends on which equations we started with. Okay, so I have a chat question. Is this because the square root is technically positive and negative? No, has nothing to do with that. So like if you're solving this, yes, you get plus or minus when you're solving with the square root method. When you factor, you most of the time get 2 answers, those 2 roots, those 2 answers. What's happening here is when we square the square root and square the line, it's creating a situation where we get this extra solution. Did you have a question, Johnny? Did I freeze? No. Was there a question? Okay, so let's practice some more. We're going to get hopefully these 4 problems done. So write down number 1. I'm rewriting number 2 for a second. Number 1 is the square root of 2x equals x plus 2. All right, so here's our same 4 steps. Step 1, isolate the radical. Okay, the square root is by itself on one side of the equal sign. Step 2, square both sides. The square root squared becomes just the argument, the 2x. But x plus 2 squared, you have to multiply by itself. Pick your method of multiplication, box method, distribute, FOIL, whatever you like. And then, do you have any multiplication questions? All right, change your equation so it's in standard form. And then we're going to vote on the efficient method. All right, so just like last week, I want to know which method with the little participants bar would we use to solve. Well, some of you are already voting. So click the green check mark if you think it's square root method, the red X for factoring, the go slower for complete the square, and the blue go faster for quadratic formula. If you're not sure, you can give me a thumbs down. I'll give you another minute to vote. I want to hear from everybody. Cecil, Ryan, Isis, Joey, Dylan, you have a vote for which method we should use, or if you're not sure, click the thumbs down. Oh, I forgot to check my chat. Anybody give me the chat? Nobody's chatted. It is complete the square because doesn't factor. B is even and A is 1. So let's complete the square. I need a little extra room. Okay. You're going to move your 4 to the left. Half of 2 squared. Factor.
Shouldn't it be -3 instead of -5?
Yes, thank you. Yes, thank you. Thank you. I was just reading that in the chat. A few of you just chatted me too. Thank you. Yes. So now when we go to do square root.
Wait, Miss Weiss.
Yeah.
A -3.
So -4 plus 1 is the -3.
Oh, got it. Thanks.
Mm-hmm. Square root of -3. We can't do that yet. This one has no real solutions. This would be the kind where the line never intersects the square root. Go ahead, Johnny.
Wait, why would it be no real solutions? Like, I'm sure it is, but like.
As compared to like getting an answer?
Yeah, because, yeah, I just don't know.
So can you square root a negative?
Oh, true, you can't. So that's why.
Yes. Now.
Okay, so because we could just tell that. I was just wondering how you could tell, but then.
Yeah, I'm not going to go any further because square root of a negative is undefined for right now. And the reason I keep saying right now or for now is because
we're gonna learn that
we're
later.
eventually gonna learn about it. Yeah.
Fun.
After winter break. But so when we're thinking about graphs and solutions, the real numbers, like, you know how we say domain is all real numbers. Real numbers are a certain classification of number types. So there's no real number solutions. There are other kinds of solutions we'll get to later. So for now, there's no real number solutions. Okay, let's try number 2. If you printed the notes, I updated this one just slightly so that we could practice this isolate the radical part. So we get the square root of x plus 2 equals x. So now, isolate the radical, I need the square root of x to be by itself on one side of the equal sign. So I'm going to subtract 2 to the right. Now we can square both sides and continue on with our solving. So I want you to try. Go ahead, square both sides, see if you can solve with the most efficient method. When you get an answer, you can send it to me in the chat. I will slowly start to show my work. All right, I got one right answer in the chat. Good job. If you're stuck somewhere, you can send me a question mark or tell me where you're stuck. Oh, another right answer. There is no decimal. How do I change the left x to 0? We subtract it to the right. All right, so your two answers to check are x equals 1 and x equals 4. And we have to check back in the original problem. And you have to check both. So I have to plug in 1, and I have to plug in 4, and simplify to see if I get a true equation. So this would give me 1 plus 2, that's 3, not 1. 1's extraneous. That works. So 4 is the only answer. So in the 9 minutes we have left, I want to definitely do number 3. If you have any questions on 2, send them to me. If you don't, go ahead and move on to number 3. When you get a situation like 3 where you have 2x equals x squared, you can never, ever, ever divide by x. We cannot divide variables. When you divide away a variable, you eliminate a possible answer. Don't divide by x. All right, let's take a vote again on our solving method. We've got x squared minus 2x equals 0. How do you think we should solve that? Square root method, factoring, completing the square, or quadratic formula? And you can give me a thumbs down if you don't know, or if you're not sure. Nobody wants to be the first person to vote? Those of you not voting, are you not sure? Are you still thinking, oh, shenanigans, I clicked clear by accident instead of more. Darn it. It's okay. I'll do better clicking next time. Hayden, you were right. It can factor. There's a greatest common factor. Don't forget to check for that. You can factor out an x. GCF, like your seatbelt in the car. Always check for greatest common factor.
I need Dad to unplug my computer because we're doing my party soon.
Today?
Yeah, since tomorrow we're going for half an hour tomorrow. We're getting together with the whole second grade meeting
Oh, okay.
for second graders, so they can see their friends before on winter break.
Oh, that's cool.
I hope I'm in the break. I won't fly.
Whole, whole second grade party on Zoom tomorrow. It's a lot of second graders on Zoom. Okay, to check our answers. 2 times 0, that's 0. Square root of 0 is 0. Yes, that works. That's an answer. Hey, 2 works. 2 as well. 2 answers for this one.
Miss Weiss,
Yes.
where'd you get x equals 0?
So when you factor GCF, x equals 0 for the 0 product property, and x minus 2 equals 0 for the 0 product property. So when it's that step of set each factor equal to 0, x is a factor. Okay, so I got a chat. Both methods work. You mean both methods, like completing the square, Johnny, and factoring?
No, sorry, I was saying that both like x, like 0 and
Oh, both
2
work. Okay, I had my participant bar over the chat, so I didn't see
Yeah.
when you sent that. Yes, both work. 2 answers. The line intersects that radical twice, 2 times. You don't have to switch the signs. Switch with signs. What signs we switching?
Like make it negative or anything?
For what? You mean when you simplify a square root?
Yeah.
Okay. When you're simplifying versus solving, solving is saying which values could you plug in for x that when you square them, you get 4. Versus simplifying is just the simplify. What times itself, like what does the square root of 4 simplify to? It's just positive 2. Can you go over difference of 2 squares again? I forget what that's like, and the flow chart says it, and I don't want to forget. Absolutely. Something like this. X squared minus 25. Oh, wait, no, wait, I'm going to make it even fancier. 9x squared minus 25. That factors to the conjugates, the opposite signs. And don't forget, in the module are a ton of videos, and they're even broken out by each method. Oh, wait, that's what we did in 3 was not. So what we did in 3 was not, no, this was factoring greatest common factor. They share something that you can evenly divide out. So if you go into the module, factoring methods or even solving methods, you can focus just specifically on those methods, not necessarily mixed together. And then in factoring methods as well, it's broken out with each kind. Okay. Nope, those are answers to classwork. Here's the homework. Get it done today or tomorrow so you have no math work over winter break. If you are missing anything in our quadratics unit, unit 2, topic 1, get it done before winter break. I sent progress reports this morning, and I can't believe TeacherView sent it to some people 10 times. And I am so sorry if you got that email multiple times. I've submitted a help desk ticket. They're aware of the issue. Sorry, but at least you got an update on where you are with your work. If you want to meet tomorrow on Zoom to go over anything, email me today and we will set up a time.